Okay, so hello everyone. The question which we will be solving today is partition labels. Okay, the question number is 763. Okay, and it is marked as a medium. It's today's LeetCode POTD. Okay, and we are going to solve it today. Yesterday's POTD, I will be uploading the solution soon. Okay, the question is good. Like it's a very good question. So, like the length of the video will also be long, so I don't have the time right now, but I will be uploading the solution soon. Okay, you can check out the solution in the the GitHub repo. Okay, you will be able to find the solution there. Okay, so now let's just try to solve this solution. Okay, let's just read the description first and we're going to solve it. Okay, so you are given a string s. We want to partition a string into as many part as possible so that each letter appears in at most one part. Okay, for example, the string ab 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 abcc can be partitioned into a b ab and cc, but the partitions such as aba bcc or something like ab abcc are invalid, right? Okay. So why are they invalid? Let me just show you. Because we want to partition, each letter must appear in at most one part. Okay. So if you have a string something like A B A B C C, if you partition it this way, here A appears and B appears. In this part, C appears, right? But see, each letter appears in at most one part. Okay, so in this case, it's appearing in one part. But if we partition something like this, in this case, A and B is appearing in this part, and B and C appears in this part. But if you will find that this B is appearing, like the B is appearing in both the parts, so that's not a valid partition, right? Okay. So how are we going to solve it? Okay, I will be taking this example AB ABC, like AB ABCC. Okay, so the things will be clear from here only. Okay, the one example is enough to understand what is happening and what we're going to do. Okay, so let me just write it. Uh, where should I write? Okay, let me just write it. So what's our string? It's A B A B C C. The numbering is 0 1 2 3 4 5. Okay, so let's say we start C. Okay, so let's just take suppose a set 1. Okay, let me just use a different color for it. Oops. Okay, let's just take a set 1, right? So this is a set 1. So we have A. Okay, we can put it into a set. Okay, we put it. We have B. We put it again, right? Okay, now we come to this A. We're gonna put, but it doesn't matter. Tell me one thing, like putting. If we can know, suppose if we know that if it's not occurring in the future, right? Okay, let me just start it again. Okay. See, suppose you have a set. Okay, this is a set, right? We come to A. We can put it. Tell me one thing, that how do we know that it's a valid partition? Because we need to have the maximum number of partitions. Okay, see, it's given that we need to partition a string into as many parts as possible. Okay, so if A doesn't occur in future, we can possibly do a partition here, right? Okay, So is A occurring in future? Yes, it is. So we won't be partitioning, right? Then we come to B. Does B occur in future? So just put it in set and check if it occurs in future. Yeah, it is. So we won't like putting it like we have B in future. So this is not a valid partition. Plus we also have a A. So now we come to this A and check. Does A occur in future? No. So like we have a partition here, but it's not complete. So let's say this is set 1 and this is a set 2. So we can we put a here, right? We can put. Then we come to B, right? Tell me one thing that does B appear in future? No. So can we put B here? Yes. Tell me one thing that after putting are these two sets equal? Yes. So can we say that we find our partition? Yeah, we did. So like in the answer array, okay, then like uh, uh, answer we can put, right? Answer we can put like 3 minus 3 have 4 elements in it. Okay. Okay. Now can we empty these sets because we have made a partition, right? Let's just empty it. Okay. Now we come to C. We put it into C. Do we have a C in future? Yes, we have. So we come to here. We put C, but it doesn't matter. Do we have a C in future? No. So we put it in. These two are again equal and we have a partition, right? So what comes here? It comes 2, right? So that's our answer, right? Okay. So how are we gonna do it? There are some like 2, 3 steps. Okay, let me just write it. What should I use? First, find the next occurrence of a element so that we know that if it occurs in future or not, right? Then what do? We take two sets, take two sets if they are equal. What do? We just tags are valid break point, right? That's our valid break point, right? And what we are doing? We have taken a set, we are taking a valid breakpoint and going to do what? Right? Let me also just insert every element in set 1 and insert elements which don't like occur in future into into what? Into set 2, right? Okay, so that's gonna do, right? That's gonna work well, I guess. Okay, so let me just go to the code and I'll think I'll be explaining some things like there are some things still left, okay, which I will be covering in the coding part, right? So let's just come to the code, and here I will explain some more things. Okay, we have taken a set. You can also take an ordered set. Okay, set by set, calculate the size, initialize an array which will be an answer, and this is next, like the next present or not, next present. Okay, this tells us that next is like the same element occurs in future or not. This is the map. First, we are doing, we are just finding if occurs in future, right? Initially, if we don't have the element in the map, then it means that it doesn't occur in future, right? If it does, then we are storing the index, okay, that it occurs at that index. Else, like, and we are updating the MP of that, okay. So I think this is very clear. Then we are setting a breakpoint. What does this breakpoint do? Like it gives you the number of elements, okay, we have inserted into it. And we check if it doesn't occur in future, we are putting it to set 2. And if set 1 and set 2 are equal, we are pushing back the I minus breakpoint. Breakpoint will give you the number of elements, right? Okay, see, like suppose this was our first breakpoint, right? So 3 minus 1, uh, like 3 minus 1 will give you 4. Okay, so we are setting the breakpoint here, okay? That's not a very, like, that's the easy step, right? And then we are setting the current breakpoint, and we are doing the set 1 and set 2, we are clearing them, okay? And at last we are just running the ARR, okay? So as you can see, the code is running just fine, and we have solved this question, okay? The question and the code link will be in the description box, okay, so you can check it out there. So yeah, that's all for this question. Have a nice day ahead.